Alright, we got another practice problem we're going to walk through here. It says to rotate the region contained by y equals x cubed, y equals 8, and x equals 0, and we're going to rotate that around x equals -2, and we're going to find the volume. I'm going to do this using washer and shell. So first of all, I've graphed the region. We know what x cubed looks like. It's bound on top by y equals 8, and on the side by the y-axis, so we got a little half bullet shaped here in the first quadrant, and it says we're going to go around x equals 2, and I said we were going to use the washer, and let me see here, x equals 2 is way over here, so we're using the washer because there is a gap between x equals 2 and the region, so we have to have an outer radius minus an inner radius. So when we use washer, if we're rotating around the y-axis, we put everything in terms of y. So since x equals -2 is parallel to the y-axis, we will write it in terms of y. And remember that the shell method, like I said, will be pi times an outer radius minus an inner radius integrated. So let's see where we get. So from x equals -2, the outer radius will go all the way back to the curve of y equals x cubed, but we want that in terms of y, so we'll get x by itself, which is x equals y to the 1/3. So y to the 1/3 tells us how far we are from the y-axis, but we're also an additional 2 on the other side, so I let that outer radius be y to the 1/3 plus 2. And the inner radius is consistent here. We're bound by the y-axis, so at x equals -2, we're always 2 away from the y-axis. So that inner radius is 2. And in terms of y, this thing is going to run from an a to b of 0 to 8. So the integral looks like pi times the integration from 0 to 8 of the outer radius of y to the 1/3 plus 2 squared minus the inner radius of 2 squared dy. Multiply, collect like terms. That gives us pi, and then the integral from 0 to 8 of y to the 2/3 plus 4 to the 1/3 plus 4 minus 4 dy. So 4 minus 4 will go away. That's collecting like terms. After integration, we get pi times the quantity of 3/5 y to the 5/3 plus 3 y to the 4/3. Remember, we're going to evaluate that from 0 to 8. Plug in 8. We get, after cleaning everything up, 336/5 pi. Plug in 0, we get 0. So our volume will be 336/5 pi. That's approximately 211 if you like decimals. We're trying to quantify how big that is. Okay, so I'm going to do the same problem using the shell method. So we got the same region. We're going to go around y equals -2. Keep in mind, if we go x equals -2 is parallel to the y-axis. So if we use shell around the y-axis, we write things in terms of x. So we're going to write this integral in terms of x. And remember, shell method is 2 pi times a radius times a height. So 2 pi. And in terms of x, the region we've got shaded in here is from 0 to from 0 to 2. And then the radius, there's only one radius when you use the shell method. It goes from -2 all the way out to the cube function. So that would be 2 for the gap plus x cubed. 2 plus x. Which is our radius, and then the height will be all the way from the top at x down, from 8 down to x cubed. Okay, so the integral will look like 2 pi times the integral from 0 to 2 of a radius of 2 plus x, and then times a height of 8 minus x cubed dx. Everything's in terms of x. Multiply it all out, collect like terms. We get 2 pi integral from 0 to 2 of 16 minus 2x cubed plus 8x. minus x to the fourth dx. Integrate that, we got 2 pi times the quantity of 16x minus 1/2 x to the fourth plus 4x squared minus 1/5 x to the fifth, evaluated from 0 to 2. So when we plug in 2, it looks like I get, once again, 336 fifths pi. Plug in 0, I get 0. So just like when I did the shell method, I get 336 fifths pi. Alright, good.